Yeah, the reality is normally very complex. You need to have a lot of knowledge to evaluate processes, even if they are always so different in the industry, varying so much. But I want to make it simple and easy to understand, so that it's also for you give something like a feast law to have a look on your own process. It first starts with a concentration. What concentration, average concentration you have? And if you can answer 0 to 500, it's a no-brainer. Then we can go directly into a basic design and help you. If you have a region between 500 and 1500 milligram, we have to go deeper into details and look about the pauses, what kind of VOCs, are they easy to degrade, etc. And as a first feast rule, I would say over 1500, we should use traditional conventional technology like RTO. With that knowledge, we also have to care for the optimal conditions for an UV or plasma application. One of them is the temperature. The optimal temperature is 20 to 60 degrees. And if it's higher, for example, when you come from a roasting process or from a drying oven, then we have to cool the air. The optimal humidity cause for formation of OH radicals is 40 to 100% humidity. And if it's below 40, I would say we moisten it. We put some water into the air. The dust and liquid aerosol particles are never good. We try to remove them in front of the UV or the plasma. But if it's not perfect possible, we have an CIP, a cleaning in place, which cleans the lamps at night or at the weekend, so that you can have a stable process. And this is very important, to care for a good, stable process by a very good CIP. Please remember that. If you have peaks, as I said before, peaks over seconds or some minutes, we are using peak smoothers, which we're reducing the peak to an average concentration, and this load on the peak smoother will be regenerated after the peak is gone. And regarding flow rate, there's no limit. We can build in modular streets by 30,000 cubic meters per hour and put them parallel one after the other. So with this portfolio of combinations, we can apply the technology as a standalone system with UV ozone or high power plasma or combinations of that. We can use it in combination with scrubbers. Its potential upgrade or pre-treatment as a pre-treatment for biofilters to activate the microorganisms with the activated oxygen we are producing, or we use it as a pre-treatment for existing activated carbon filters, where we are changing the role of the activated carbon from adsorption to catalysis. Because the catalysis is a very important reaction to remove residual ozone and to put together residual VOC and ozone particles on the AC surface. And last but not least, we can also go for replacement of RTOs, thermal or catalytic oxidation systems, or if it's needful to make a post-treatment after an RTO has done the main of the work but doesn't reach the final limits, then it can be a post-treatment.